This is an introduction video to SpatialAL. SpatialAL, short for automated learning, is a tool that plugs into our spatial products that performs automated machine learning to predict variables like profitability, turnover, etc. for things like potential new store locations. The tool can be found in the Data tab of our products. Before we use the tool, we will have some things set up. First of all, you can see I have all my Blue Nova stores plotted on the map in South Africa over here. Now, the next thing that I will do is create territories around the shopping centers that have these Blue Nova stores of a certain drive distance based on certain parameters, such as the type of shopping center, whether it's neighborhood, lifestyle, regional, super regional, etc. And this is what the territories look like that I created around my Blue Nova stores. The next step is to aggregate all possible data and information into these territories, such as demographic data, neighborhood lifestyle index, number of competitors within the territories, etc. Here is a snapshot of what that data looks like that was aggregated. So first of all, you can see here, these are the territories of my current Blue Nova stores. There's 200 of them in total. And we can see I have these turnover amounts for each of these stores. These are actual turnover amounts that currently exist, and I'm going to be using SpatialAL to actually predict turnover for potential new store locations. So anyway, back to this, we have my 200 current territories for my stores, and you can see into these territories I aggregated a whole bunch of different data, such as the number of competitors within each of the territories here, neighborhood lifestyle index data in all of these territories, age breakdowns, working population, number of households, various different data as much as possible into these territories, and all of this data will be used as input for the machine learning so that it can pick up patterns about these current stores so that it can predict new potential locations and predict the turnover for those locations. Alright, and then this is just another visual of how that aggregated data looks within all these territories. To see it graphically here, you can see neighborhood lifestyle index, age, gender, working population, further information, and much more, all aggregated into these current territories. Alright, the next thing to do was to create territories now around all shopping centers in South Africa where there isn't a Blue Nova currently, but where there potentially could be. And so these territories were created here. As you can see, they are my shopping centers with the territories created around them where there are no Blue Novas. And as you can see, these ones which don't have territories made for them are where there already are Blue Nova stores, so they won't be considered. But here are the territories that I created. And similarly, as I did with the current stores, I aggregated all data possible into these potential new store locations so that I could use that for the prediction that I will be doing with SpatialAL. You can see here for these shopping centers, which are, if I do a count here, about 1,700 in number, where there aren't a Blue Nova store. You can see we don't have turnover data for these stores, but we want to predict and see if there was a Blue Nova store placed there, what would the turnover be? So that's what we're going to be doing. But for now, we first just aggregated all data possible into these territories I created, such as number of competitors, neighborhood lifestyle index, etc., as I said before, or aggregated into these territories as well. The same fields that are aggregated into the current store territories are aggregated into these potential new store territories. Okay, now we come to the next step. I'll be running a certain machine learning model known as regression to predict the certain variable which I'm interested in this case, which is turnover for potential new store locations. So the way that's typically done is you would break the original data set, which is this one with the current store territories with 200. You would break that up into 80% and 20%. And you would do the training of the machine learning with 80% of the current data. And I'll show you how that looks like. Okay, so as you can see here, this is 80% of the 200 total Blue Nova stores that exist. So you can see 160 are here, only 80, obviously with their turnover values there. And I'm going to be using this set to train the machine learning model so it can pick up patterns and learn, and therefore be able to predict new potential locations. So now that I have this 80% set, which I've named train over here, you can see, I'm going to open the SpatialAL tool. So the SpatialAL tool will be applied to whichever layer you currently have selected in the layer control. So I'll make sure to select the correct one here, which is the train one. Alright, it has now brought up the tool, and here it is. So this is what the dialog looks like. Now to create a new model, you'll just click the plus sign here, or you can open ones that you have saved out already. So I'm going to create a new one, and I'll just give it a name first of all. I'll call it BN for Blue Nova, and the description I'll say potential new locations, turnover. Alright, then we have the timeout in seconds, which is 600 seconds here. So this timeout refers to when I'm going to be training the model on the data, and it basically goes through a whole library of possible models to use and find which one will fit best to predict your data with. And it will keep running and keep going through a whole number of models until you actually tell it to stop or set a timeout. So you can set a timeout here. I'll just leave it at 600 seconds. I'll show you how that looks shortly. Then we're going to choose the model type. So we have currently these model types available to use for machine learning. There's binary classification. So that's if you want a yes or no answer. It's either this or the other thing sort of answer that you're trying to predict. That's binary classification. Then you have your multi-class classification, where you want to categorize things into a number of different classes like high, medium, low, for example, that sort of prediction. And then we have regression, which is where you want to actually predict a certain variable and see how other factors influence and lead to that variable and use that to predict it. And this is the type of model we'll be using here in this example. And then you have a recommendation type model, which picks up maybe what would be the most likely next thing someone or something would do based on their past behavior patterns. And that's a recommendation type of prediction. And then you have a ranking type of prediction where it will rank things in order of whatever it is you want to rank it in. Right, so I'll choose regression. The next thing we're going to choose is the output column. This is the column that you're actually wanting to predict and get an output of a prediction. So in this case, in my 80% set of data of my current stores, the thing that I would like to predict for potential new locations is this turnover value here. So I'll choose the turnover column. Next is the input columns. This is all the data that you're going to input into the machine learning program here so that it can take that input data and run through it and learn and pick up patterns to develop a prediction model. So in this case, I'm going to choose basically everything, but tick off the few things that I don't want input, such as geometry, row, unique ID, etc. I won't put in the turnover as the input because that's the thing I'm trying to predict, which is the output here, so I'll tick that off. And then pretty much everything else is in here, the neighborhood lifestyle index, number of competitors in each territory, race breakdowns, all of this data I'm putting as input. And at the end here, I'll just tick off some other unnecessary things. And there we go. These are all my input columns that I'm choosing to put into this machine learning program. I now have everything set up and I'm ready to train my model. So as I said, it will be applied to whichever layer you have selected here. And then this button will train the model and it will run through a whole library of different potential models and try to find the best fit to use for your data. So I'll now click this. As you can see down below at the status bar, it's running through different algorithms to find which is the best. And it's busy training now and learning from the input data that I've given it. And it will continue to run until my timeout is reached over here, which I put as 600 seconds. You can stop the training beforehand if you don't want it to continue any longer, and it will use whichever model it found as best as possible that it found in the time period that it was training, and it will use that. And to stop it, you just press cancel and it will stop. Okay, my training is now done and the model has been created and trained, and it can be used now to predict values. So typically the next step after training on 80% of your original set of data, you would then apply it to the remaining 20% to predict the turnover there and see how the predicted turnover will differ from the actual turnover values. And that will let you know if your model is working and accurately predicting your data. So that's what I'm going to do at this point. Over here, now I have selected the remaining 20% of my original set of 200 Blue Nova stores, and that's 40 of them. And this is my test set. And then to now apply this model that I just trained and created to this remaining 20%, I'm going to drop down here and choose the actual column where the predictions will be populated in this 20% data here. So I did add a column in this data called predicted turnover, which I'm going to choose to have where the values will be populated. And there we go. Now that I've selected that, I can click the apply button over here to apply the model to this remaining 20%. And there we go, it is now running and applying to this 20% here. Alright, it is now finished and has completed applying to that 20% of data. I'm going to minimize this, and now I'm going to look at our results here and see how they look by viewing the data of this 20% validation set that I'm using to test the model or validate it. And there we go. Here is the actual turnover column, and this is the predicted turnover column, and we can see now the differences between the two. What I also added was a calculated column called Variance to calculate the average or get the variance between these actual and predicted amounts, so I can get an idea of how far off the prediction was. And as you can see, there's an average variance of 0.59%, which is extremely small, which means my model is actually successful and is predicting correctly. So my model can now be said to be validated at this point. Now, typically before I apply this model to potential new locations and new data, I would, before I do that, train the model again, but now on 100% of the original data, because the more data that the model has or has been trained on is always the better, because the more you learn or know, the better you'll be able to predict things. So that'll be my final step. After I've now validated it, I'm just going to retrain it on 100% of all the current stores so it can have as much data as possible, and then I'm going to apply it to these new territories where there are no Blue Nova stores. So I have my original 200 stores selected here, territories, and then I'm going to bring up the SpatialAL window here again. Alright, and now I'm just going to clear this because I'm not applying it, but I'm just going to be training it again, so I'm going to make that blank. And I have the 200 stores selected here, and then I'm going to click train so that it can now train on all this data. It is now training on all the data, and the training is now complete. Now this model is ready to be applied to new potential locations. Now before I actually use it, I can at this point actually save out this model now so that I can load it again at a later date and use it by clicking save model or save as. And if you had a number of different models open here using this open feature, then you could click save all open models and it'll save all of them at once for you. Then also just over here, this about is where you actually license your SpatialAL here. Okay, so my model is ready, it's been trained, and I'm going to now apply it here to these shopping center territories that I created where there are no Blue Nova stores, which look like this. So first of all, I'll just make sure the layer is selected here in the layer control. Then I'll bring the window back up here. And now what I'm going to do is within this set of new data here, I'm just going to choose the column where the predicted values will be populated. Again, I did add a column in here called predicted turnover where the values can be populated. So I'm going to choose that. And then I can go ahead now and then click the apply button to apply the model to all 1,759 shopping center territories where there are no current Blue Novas and get a prediction of what their turnovers could be. So I'll click the apply. And it is busy applying now. It'll run for a while until it's done. And it has finished applying it and it is done now. So now I'll take a look at the results by actually viewing the data of this set of shopping centers. And here it is. We can see the predicted turnover column that I added. So over here, it's now been populated with predicted values for these 1,700 shopping centers where there are no Blue Nova stores. And I have predictions now of their potential turnovers. And now, because this is an add-in to our spatial products, you can do full theming and analysis now on these predicted values for these potential new locations and see how they compare with the current and where would be a good place to place a new store due to its predicted value. So for example, here you can see I applied a color theme as well as putting text labels of the predicted turnover amounts for these shopping center territories where there are no Blue Nova stores, and I can actually analyze and look here nicely and maybe only isolate the high turnover values here and say isolate and just look at those locations and see about them. And another thing now you can do is actually create dashboards on these locations using our dashboards feature to pull out the various underlying data that we previously aggregated into these areas to actually see what are the demographic, etc. profiles of these different territories that now have predicted turnover values, and you can analyze that. So I'll bring up the dashboard here, for example. Here we go. So here's the dashboard I've set up. I have it on filter on selected, so I can actually go to these predicted territory locations and then select them, and then it will pull out the graphs, etc. for all the data in that territory. So for example, I'll select this one here, and there we go. I can get a picture of the neighborhood lifestyle index in that area. I can see here it's a very high NLI area. We can see the age breakdowns, gender, working population, all of this different data for these predicted new territories. Right, and that is how you can use our SpatialAL product to predict variables of your choice and actually come to good business conclusions about an area. And that's all for this demonstration. Thank you very much.